All right, here's an example of an ellipse, basic one. I have x squared over 25 plus y squared over 9. So because that's a plus, I know it's going to be an ellipse as opposed to a hyperbola. And these contrived problems are very nice because 25 and 9 both happen to be perfect squares. So A is going to be 5 and B is going to be 3. So remember that the A is always bigger. So because this big number is under the x, I know this is going to be a horizontal ellipse. So if I were to sketch this briefly, looking for, let's see, we're going to find a vertex. We're going to find the co-vertex, or co-vertices. There's two of them. And we're also going to find the focus, or the foci, and eccentricity. Eccentricity is interesting, but it's pretty easy to figure out. Eccentricity. All right, so first things first. Let's agree that A is 5 squared. I'm writing it as 5 squared because I need the A, or this is A squared, because the general form looks like this. So y squared over b squared, and it's going to be equal to 1. So I guess that makes my A a 5. So let me just erase that. So A is 5, and B is 3. So I have two pieces that I need. The other thing that we're going to need to find the focus and eccentricity is we're going to have to find what C is. And the relationship of C is this. C squared equals A squared minus B squared. Don't confuse this with Pythagorean theorem, which would have a plus here. So this is not a hypotenuse. Actually, this is. But anyway, so here we go. I can find my C here because C squared equals A squared minus B squared. So with these contrived problems, everything usually works out pretty nicely. So 25 minus 9, that gives us a 16. So that means that C is equal to plus or minus 4. So when I go to graph this, I could graph the foci, but first we'll just list what they are. So my vertex is going to be, let's see, 5 and 0, and negative 5 and 0. And my co-vertex, my co-vertices are going to be 0, 3, and 0, negative 3. The foci are going to be, let's see, I got a negative 4 and a 4. And the eccentricity is C divided by A. So C happens to be 4 and A happens to be 5. So the eccentricity would be 0.8. It's always a number from 0 to 1. But what it does is it kind of, the higher the eccentricity, kind of the flatter the oval is how that works out. So let's take a pause and go and look at a sketch. All right, I'll see if I can fit this stuff on the same screen so that we have the values that we calculated to look at. So first I'm going to plot the vertex, the vertices, 5, 0, and negative 5, 0. So 5, 0 is going to be, I'm going to say it's out here, 5, 0. And then negative 5, 0, that's going to be out here somewhere. So there's the two vertices. Now, next we'll look at the co-vertices, which are on the short or the minor axis. So 3 is maybe going to be up about here. I'm just eyeballing this up, and negative 3. So that gives me my 0, 3, and this is where our 0, negative 3 would be. So we kind of have the beginnings of a sketch here. So I'm not usually very good at sketching these ovals, but kind of looks like a crooked football. But anyway, let's see. The next thing we have are the foci. So the foci, the focuses, if you prefer, are on negative 4, 0, and 4, 0. And those are always going to be on the major axis. So this one was negative 4, 0, and this one was 4, 0. All right, so now maybe I can make this a little bit bigger. Oops, forgot my parenthesis there. So what we have is just a sketch of this. Let me point at the pieces again. Our vertex, vertices, our co-vertices, and I need a parenthesis there too. The center, which is on the origin with the form we looked at, and then our foci. So remember, the foci are the two places that when you drew the picture, or if you've seen this in grade school maybe, wrap some string around two thumbtacks and then just traced with a pencil from this point, and it drew a perfect ellipse. So what's nice about these contrived problems is that these numbers here, the 4s, were made to work out so that you didn't have square roots and things like that. So, but anyway, there you have it. A quick graph of this function. It's not a function, but of this x squared over 25 plus y squared over 9 equals 1. All right, let's look at one more on the next slide. So here's another presentation of an ellipse. So notice it has 9x squared and 4y squared, and it's equal to 36. I want this to be equal to 1. So the trick here is just divide everything by 36. This is what we would do to get it into the form that we want it in. So that leaves me with what? X squared over 4, because 9 goes into 36 4 times, plus y squared over 9, because 4 goes into 36 9 times, and that equals 1. So notice also here, the bigger number is underneath the y, so that means the major axis is going to be vertical. It's going to be up and down. So when I go to sketch this, it will sketch like this. I'll draw it more like this. So the oval, or the ellipse, I'm going to call it that, is going to go more like this. So I need to find the vertices, the co-vertices, and the foci, which will be in here somewhere, and the eccentricity. So let's do this. Let's agree that a is equal to 3. Remember, that's coming from underneath the y squared, because the a is always bigger than b. So that makes my b equal to 2, because 2 squared is 4. So 3 squared is 9, 2 squared is 4. It's going to be a little bit different this time, because I'm going to have a radical. So this would be 3 squared plus 2 squared, I'm sorry, not plus, minus 2 squared. See, I almost did the Pythagorean theorem thing. So that's a 9 minus 4, and c squared equals 5. So that tells me that my c is plus or minus radical 5, or square root of 5. All right, so I will start with my vertices. So here's a let me switch colors. Here's one vertice at 0, and then I go up 3. And here's another vertex at 0, down 3. All right, on the minor axis, right, the minor axis going this way is where I will have my 2, 0, my co-vertices, and this is a negative 2, 0. So co-vertices. The center, of course, is at 0, 0. Don't know if I have to put that in, but I will. So we want to find the foci. So they're going to be around in here somewhere. And they have, let's see, root 5. So this is 0, positive root 5. And this would be 0, negative root 5. So there we have found our vertices, 0, 3, and 0, negative 3. Let me grab that. And then co-vertices, negative 2, 0, and 2, 0, because this is the minor axis. This is the major axis. And then the foci, which is 0, c, and 0, negative c, because we're on the origin, right? Center's on the origin. And we got our c as plus or minus root 5 from our formula, c squared equals a squared minus b squared. All right, the last thing being asked for was eccentricity. So eccentricity is c over a. So c, square root of it, 5, but I'm going to take the positive, and let me see, over a, which is 3. So this is the eccentricity. If you want to, you can get a decimal for that. I do believe the square root of 5 is somewhere around 2.236, I want to say, over 3. So again, that's got to be a number between 0 and 1. And the closer it gets to being a 1, the more squinched it would be this way. So it's like a squished football. It just measures the squishiness, I guess you'd call it, of the ellipse. All right, so there is another example. So let's go ahead and see if we can find any other examples to look at for you there. All right, so let's suppose we had one and all we have to do is graph it or sketch a graph. So what we're going to do is look at, see if we have to rearrange it at all like the last one, but nope, this is x squared over 25 plus y squared over 20 equals 1. So it's in standard form, or the form I want it to be in. And I notice 25 is bigger than 20, so this is my a, or my a squared. So a squared is 25, which makes a equal to, let me switch these colors up, a equals 5. And over here, b is going to be the square root of 20, or I guess that's about 4.5, if we want to estimate that. So, well, that was sort of a sloppy 5, wasn't it? 4.5. All right, so going over to the graph, I would count 1, oops, let me do another color, the same color. 1, 2, 3, 4, 5. Too bad I didn't have graph paper on this. And it's going to be almost a circle. So we're not asked for the eccentricity on this one, but if I figured it out, it would be closer to 0. So first things first, 0 and 0, that's the center. 5, 0 is one vertex. That's a comma 0. Negative 5, 0 is the other vertex. And the co-vertices are about, if we're estimating, that'd be 0, 4.5, say, and down here would be 0, negative 4.5. So that's my sketch. So again, these are called the vertices, okay, vertex, vertex. These are called the co-vertices, vertex, vertex. So I have everything I need to do the graph of this. So I'm going to go ahead and maybe we'll change it to red. I think it's easier to draw a circle than an ellipse. So notice this is, even with a rough sketch, this is closer to being a circle. So the eccentricity, well, I didn't figure out my c here, but c divided by a is going to be closer to 0 than it is to 1. So might as well do that just for good measure. So eccentricity is c over a. So I didn't figure out my c, so let me use my formula. C squared equals a squared minus b squared. So c squared equals 25 minus 20, or c squared equals 5, or c equals plus or minus radical 5. So that's would put those right around here, my c's, because the square root of 5 is 2.236. In any event, square root of 5 divided by a, which is 5, I'm going to punch this right into my calculator, and as I suspected, it's closer to 0 than it is to 1, which means it's closer to being a circle. A circle is actually a special form ellipse. Its eccentricity would be 0. So in any event, thanks for tuning in. I appreciate it, and stay tuned for the next one.